Okay, so what I want to look at in this lesson is a fascinating subject in mathematics, which is known as trigonometry. And trigonometry, really what it looks like the study of triangles. And it's the measurement. Metry comes from measurement or putting measurements or units on triangles. So what we're going to look at is Pythagoras' theorem. Now, if we think about Pythagoras, so Pythagoras was actually a person who was alive around 500 BC, so quite a long time ago. And his ideas that he came up with have lasted a long time, and they're still with us today. And we teach them. We still teach Pythagoras' ideas today, and a lot of the concepts and what comes out of his ideas are used in modern society, in engineering and maths and science as well, in lots of very practical ways as well. So Pythagoras was a Greek philosopher, and he came up with his theorem. So Pythagoras, 500 BC, he grew up on an island in the Adrian Sea. So this is the island that he grew up on, Samos, and it's this beautiful Greek island, which is a beautiful holiday destination at the moment. So that's where he grew up in ancient times, in ancient Greece. So this is just kind of he may not have actually looked like this, but it's an artistic representation of what he looked, because it's a long time ago, 500 BC. We didn't have cameras and Facebook and all of that, all of the modern technology that we have today during that time, so we don't know exactly what he actually looked at. So this here is just what this island in Samos, what it actually looks like. So you can see it's quite beautiful, and this is really, if you like, where this is the genesis, or where this Pythagoras' theorem has actually come from. And so you might wonder, why are we studying this today? So if we think about, trigonometry then is, we're looking at the study of triangles. So what we have here is a triangle. Now this is a 90-degree triangle. So what that means is that if you were to take a protractor and you were to measure this angle here, it would be 90 degrees. Now, something that we need to kind of understand in relation to trigonometry and Pythagoras' theorem, so that we can kind of make sense of it. If I take a line like this, so this line is made up, and then we divide it. So we have, let's break it up into its divisions. So we have a line here so we can say 1, 2, 3, 4, 5, 6. It's split up into 7 units. Now, if we take this 7 and we square it, like, what do we mean by that? What are we actually doing? So 7 squared is equal to what? So it means 7 by 7. And this is something that's really important, so that Pythagoras knew as well. So let's say if we take, so essentially if we want to square this, so we've 1, so imagine, so we've 1, 2, 3, 4, 5, 6, 7. So if we were to take a line and draw it from here to here, so when we square something, what that actually means is that we are creating a square. We're taking whatever the unit is, and we're creating a square based on that unit. So in this case, we have this line is split up in 7 units. So if we want to square this, essentially what we're doing is we're creating a square like this. So it's a 7 by 7 square. Okay, so it looks something like that. So if you think about within this box, how many squares do we have? So 7 by 7, so we've 1, 2, 3, so we have 8, 9, 10, 11, 12, 13, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49. So we have 49 squares here. So if we take 7 and we square it, that's what we mean. So we're taking a length, we're taking a line, we're splitting it up into 7 sections, and then we're making a square out of that. And then we're trying to figure out how many individual squares then do we get within that. So 7 by 7 is 49. So if we think about it, so back during Pythagoras' time, they wouldn't have had calculators. So very much a lot of their maths was kind of done like this, based on simple geometric shapes. So this, if you like, so 7 squared means this, and it's equal to that. But this here is a visual representation of what 7 squared means. You're taking a length that's 7, and you're breaking it up into a square that has all of these individual numbers of squares within it. And that's what 7 squared means. Now, with Pythagoras' theorem relates to triangles. So what we have here, so imagine we call this side A, this side C, and this side D. Sorry, B. A, B. So A, B, and C. So Pythagoras' theorem, what it states is that this side, your bigger side, so A squared, is equal to C squared plus B squared. So what does that mean? What it means is that if you were to take, for example, you were to take B and you were to make a square out of this with the length that we have here. So we make a square something, and this is not exactly the way that it is, but if you're to take it and make a square then from here, so you make a square, so this, you make a square with this length and you make a square with this length, and then if you are then to make a square with this length here, remember a square, all the lengths are the same size, something like this. So again, this isn't exactly perfect. Okay, so if you count up the number of squares that you have in here, and you count up the number of squares that you have in there, and you add these two together, it's going to be equal to the number of squares that you're going to get in here. So essentially that's what Pythagoras' theorem means. It means whatever square that's made by this long length that's on the triangle, you make a square out of it and you count up all of the sections within that, it's going to be equal to the number of squares that are made if you make a square with this length, plus the number of squares that are going to be made if you make a square with this length. Another way as well that you can think about it is that the area of this that's made up with a square of length A is going to be equal to the area of a square that's made with the length C and the length B combined. So that's what we mean by, so this is where Pythagoras is coming from. This is what Pythagoras' theorem actually means. So what I can do then is, if we look here at a more kind of detailed example. So remember what Pythagoras is saying is that in relation to this diagram here, C squared is equal to A squared plus B squared. So if we think about, so c squared, how many boxes do we have in here? So we've 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So we've 20, so c squared is equal to 25 boxes. So 25, so that's going to be equal to a squared. So remember, this is a squared. How many boxes have we got? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. It's equal to 9 plus b squared. So this is b squared. How many boxes have we got in b squared? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So plus 16. So if we add the two of these together, 9 plus 16 is equal to 25. So 25 is equal to 25. And that's all. That's what Pythagoras, this is what Pythagoras noticed. And this is like it's something that's very visual. It can be observed when you look at triangles. When you square this length, it's going to be equal to this length squared plus this length squared. And that's where this comes from. So this is what we mean by Pythagoras' theorem. And Pythagoras' theorem, visually, this is what it looks like. And this line across here, so C, for example, this line here, this was called the hypotenuse. So just if we put a name on it, so this is the hypotenuse. And the hypotenuse is always opposite the right angle. So this here is the right angle. And the hypotenuse is always opposite that right angle. So these are some of the, so then if you were to put it into words, Pythagoras' theorem, it means the square on the hypotenuse of a right angle triangle is equal to the sum of the squares on the other two sides. So this is the square of the hypotenuse. So this line here represents the hypotenuse. So if you square that, what this is going to be equal to the sum of the squares on the opposite two sides. So the sum of this line squared and this line squared. And this is what it looks like if we write it out. And we use symbols, but this is what it looks like visually if you're to break it down and look at it. So what I'll do just in the next lesson is we'll take some examples of problems that you could be asked to solve using this information that we've just learned. Okay, so thank you for listening.